Nothing kills automation efficiency faster than failed webhooks that halt your entire process. Seriously, it's the absolute worst. Welcome back, everyone, to Module 4 of our AI and Automation Masterclass. We've been laying down the foundation, right? But today we are getting into the actual nervous system of digital operations. We're talking about the real risks of poor architecture, those sneaky hidden traps of data integration, and most importantly, how to build systems that literally just do not break. All right, so the core goal of this explainer is to completely demystify the underlying mechanics of low-code automation. We're going to look right under the hood of industry giants like Make.com and Zapier to understand exactly how they chew through data. And I promise you, by the end of this session, you won't just be connecting apps together. No way. You will be architecting really robust, totally error-resistant pipelines capable of handling massive enterprise-level workflows. Here is a quick look at our roadmap for today. We're going to start with the low-code abstraction layer, compare polling versus webhooks, examine the runtime topologies of Zapier and Make, explore routers and data logic, and finally, we'll actually build an enterprise webhook pipeline together. Sound good? Let's get right to it. Section 1, the low-code abstraction layer. So the very first thing we need to wrap our heads around is that low-code automation isn't just magic. It's highly structured, brilliant engineering. At its core, low-code automation simply takes complex API integration architecture, data parsing, and webhook handling, and abstracts all of that into a visual, event-driven workflow. But what does that actually mean for you? Basically, it means you're completely eliminating the need to write monolithic backend middleware from scratch. Actually, scratch that. It's more like instead of spending weeks manually coding HTTP protocols, you are seamlessly binding distinct cloud platforms together on a visual canvas. You get to execute all that complex logic without writing a single line of syntax. It's a total game changer. Moving right along to Section 2, Event Triggers, Polling versus Webhooks. Okay, so this is where the automation literally wakes up. Every single low-code sequence relies on an initial event listener, and these operate in basically two main ways. Think of polling kind of like a kid in the backseat of a car repeatedly asking, "Are we there yet? Are we there yet?" The automation engine is just continuously querying an external API at set intervals to check for new data. And honestly, it generates a ton of empty calls, which just eats up your network resources. Webhooks, on the other hand, are so much better. They're like an active GPS notification. You don't even have to ask. The exact moment a state mutates in the source app, it actively pushes a real-time JSON data payload right to you instantly. But, because webhooks are instant, they do introduce some pretty specific reliability challenges. For one, webhooks are almost always one-time events. So if your system happens to be down, that source application isn't going to just magically resend the data. Because of that, relying on webhooks absolutely demands structural error handling, sophisticated retry mechanisms, and something called exact idempotency. That's just a fancy way of saying your system needs to be perfectly designed to safely ignore accidental duplicate data pushes. Because let's face it, nobody wants to accidentally double charge a client. All right, Section 3, Zapier versus Make runtime topologies. So now that we actually have our data ingested, how do our two platform titans orchestrate this whole cloud infrastructure? Well, when we contrast their execution styles, the architectural differences are pretty stark. Zapier operates on a super linear, step-by-step procedural execution style. It abstracts all the heavy lifting for you, which makes it absolutely brilliant for rapid setups of standard operational tasks. Make.com, though, formerly Integromat, employs a visual graph-based topological map. It handles multivariable, iterative arrays, infinite database loops, and even native JSON arrays. Basically, this gives Make computational parity with traditional backend scripts. So if you need deep customization, Make is for sure your go-to. But wait, what happens when a really critical order hits an error halfway through the process? Imagine a customer's payment clears perfectly, but then, boom, your inventory database times out. Yikes, right? Well, this is exactly where Make's advanced error handling absolutely shines with commit versus rollback. A commit means actions are permanently executed, like successfully processing that payment. But a rollback? That allows the system to completely reverse uncommitted actions if an error pops up later on. It essentially returns all your systems right back to their pre-scenario state, completely preventing any corrupt or partial data entries. For enterprise operations, having that kind of massive safety net is absolutely crucial. Let's move to Section 4, Routers, Filters, and Data Logic. To really wield that kind of error handling power, we need to introduce the steering wheels of our automation engines, structural logic nodes. These guys let us natively manipulate the payload layout as it transits between modules, and get this, we do it without a single line of traditional code. It's awesome. Routers split a single execution stream into multiple parallel paths based on multi-conditional rules. Think of them like train track switches. Then you have filters. These act as super strict bouncers, inspecting incoming JSON objects to instantly stop executions that fail specific criteria. Finally, data operators let you execute native string manipulations and math directly on the data while it's in transit.
Okay, section 5, building an enterprise webhook pipeline.
Let's take all of this abstract theory we've been talking about and actually assemble a tangible, step-by-step practical implementation blueprint. Try to mentally map this visual node flow topology with me, okay? Step 1, our webhook listener node instantly catches that inbound data payload. Step 2, that payload slams right into a data filter that's checking for premium lead validation. Step 3, the data enters a router array, splitting into two totally distinct parallel paths. Path A is strictly for our premium leads, firing an action to insert a row right into an Airtable database. Meanwhile, Path B is our standard lead path, which immediately fires off an alert to a Slack channel. So let's actually look at the raw data flowing through those nodes. Here's our sample input JSON webhook payload. We've got a lead ID and the name is Alex Mercer. But check out that key data point right at the bottom, an estimated budget of $12,500. I want you to keep that exact number in mind as we evaluate the logic on the next step. Right here is the code equivalent syntax of our low-code setup, and this really proves its total parity with backend scripts. If you look closely, our filter criteria require the estimated budget to be greater than or equal to $10,000 to qualify as a premium lead. And because we know Alex Mercer's budget is $12,500, this specific data packet dynamically triggers the premium tier paths. It completely bypasses the standard tier entirely, routing perfectly right into our database insertion engine. Clean, instant, and completely automated. The whole shebang. So, we've laid the foundation, mapped the topology, and totally proved the logic. You now understand the really profound difference between just a basic, simple integration and a truly resilient, logic-driven pipeline. But I want to wrap up this explainer by leaving you with one incredibly crucial thought. Okay, your pipeline is built, it works flawlessly for one lead, maybe even 100 leads. But how in the world will you handle the data when it scales to 100,000 simultaneous webhooks during a massive global launch? Seriously, think about your rate limits, think about your rollbacks, and really interrogate your architecture, because figuring that out, that is where true mastery begins. Thank you so much for joining me for this explainer, and I will see you in the next module.